Hi guys, Mr. Bennett here. Now in today's video we're going to be looking at rotations. Alright, so what does that mean to you? Well, it means that I can rotate a point around another point, a certain distance, a certain angle, and we should be able to find where that point goes using matrices. Now the information you've got here is you've got this matrix here which is your rotator, I suppose. So we might call this the rotator. And this is the point that's going to be rotated, and we always put that in the form of x and y. All right, now a couple of things that you should know about this particular rotator point. Now if we're using our unit circle, and I think it's important that you see this, our unit circle, we would have points 0, 1, just erase that. So these points in our unit circle, which we learned in our previous topic, 0, 1, okay, and we're always going to rotate anti-clockwise. So this point here is 0, 1, and we've got this point over here which is -1, 0, and this point over here which is 0, -1. Now remember, when we did our unit circle, the x coordinate and the y coordinate, well, the x coordinate was cosine of theta, and the y coordinate was sine theta. Alright, so if you remember back there, we're going to use that. So, I mean, obviously, when we're thinking about using that, so let's say I was going to rotate 90 degrees. Alright, 90 degrees, then what we know is that at 90 degrees rotation, we're rotating this point here 90 degrees there, that direction there. So if we were doing that, we know that we're going to get to that point which is point 0, 1. So that means that cosine of 90 is in fact equal to 0. Sine of 90 is equal to 1, but it's -1 there. That would be 1 and that would be 0. So that would be the matrix I'd be timesing the other things by. Now if it was 180 degrees, then my matrix C would become the following. Well, we know cosine of 180 is -1, so that'd be -1. Sine 0, that would be 0, and then that would be -1. Alright, so if we did the next one, so if we were looking at 270 degrees, then what we're looking at there is 0, -1, so cosine's going to be 0, sine's going to be -1, so -1 is going to be 1, -1, 0. So that's what these matrices will become, depending on if you're going 90, 180, 270, but you don't always have to rotate that much. Okay, so therefore it could be a fraction or whatever. Alright, that's the key process what we're looking for here. So let's do an example really quickly. Alright, so let's say I was going to rotate this point here, and let's find a point, let's make one up. Let's rotate this point here to 1, and we're going to rotate it. I'm going to rotate it 90 degrees, just for a nice simple example. Alright, so remember my matrix here, which is cosine theta. Alright, or let's write this straight away in cosine of 90 minus sine of 90, sine of 90 and cosine of 90. And what I'm going to do is I'm going to multiply that by 2 1s. So that's going to be 2 1s, my matrix there. Alright, so that's what I need to do. Now I can write this here, we've already done that previously. We know that cosine 0 there, that's going to be -1, 1 and 0. Alright, so we have to remember what our matrix multiplication is. So remember what we do when we're multiplying matrices, we go our row by our column. Alright, that's what we're going to do to solve this. Alright, so let's do that. Alright, so that's equal to, I'm going to have 0 times by 2. Alright, and then I'm going to have 1 times by -1. Now I can do that in my head. I can write that as simply -1. It's a pretty simple one to do. All right, the next one I'm going to have 1 times by 2, 0 times by 1. That's going to be there. All right, so what that means is, if we come up to our example up here, our coordinate, well, our point here, is our new point is going to be -1, 2. So come to our axes here, let's draw this. All right, so -1 there and 2 up that way. So it's going to be rotated to that point there, which is -1, 2. And it's going around that way, 90 degrees. Alright, so that's simply what you're going to need to do in order to show rotations. Now obviously when they become not equal to 90 degrees or 45 degrees or 30 degrees, I can still use my unit circle, right, for those ones there as well. So if it was basically rotating 30 degrees, then I could use my triangle over here, which is a 1 √3 and 2, and so therefore I could go, all right, sine of 30 degrees, sine of 30 degrees is equal to 1 over √3, sorry, 1 over 2. Okay, so I could say sine of 30 is equal to 1 over 2, and I could go cosine of 30 is equal to √3 on 2. So if I'm looking for an exact answer, all right, then I can actually do the same thing. So the only thing that's going to change, if I was doing the same thing but rotating 30 degrees, my matrix now would become the following. All right, cosine would be √3 on 2. All right, sine's going to be -1/2. It's going to be 1/2. It's going to be √3 on 2. I'd be timesing it by the point which is 2, 1. Let's do it. Okay, do the algebra bit. All right, just so you see it's not that hard. Okay, again, do the same thing. I'm going to have √3 on 2 times by 2, and that's going to be take 1/2 times by 1, which I'll need to simplify. I'm going to 1/2 times by 2, and then it's going to be plus √3 on 2 times by 1. Now the top line, I'm going to cancel the 2's there, so that's going to be √3. That's going to work out to be √3 1/2 times by 1, so it's going to be √3 take 1/2, which we can work out. The top line's going to be simply, the bottom line's going to be that 1/2 times by 2 is going to be 1, and that's going to be 1 plus √3 on 2. Now you could go to your calculator and exactly work that out if you wanted to in terms of decimals, but that's probably an exact answer anyway, the way I presented that. Right, hopefully this helps, and it's pretty simple to do rotations. The only things that you need to remember are basically this stuff up the top here. All right, so that's what you need to remember, which is that diagram, that matrix, and making sure you're putting X and Y in the order there. Right, good luck with the questions, and make sure you catch up if you need some help.